this 2015 IEEE Symposium on EDA and IP interoperability. Be introducing the keynote speaker. I think we have a very good presentation for you today, starting with the keynote and going through a number of low power issues, the celebration of the System Verilog, 10 years of System Verilog, plus a look forward as to what's happening in the IEEE and standards, followed by more low power issues in the afternoon. And then we have a special presentation from some of our Japanese colleagues from JEDA that will be talking about the IEEE 2401 LSI package board standard. This recently was standardized in the IEEE. So we have a full day. We have a lot of people registered. I'm assuming they'll start filtering in as the day. People like to be fashionably late in Silicon Valley, so they'll start filtering in. We do have a pretty good crew coming in, about 20 people from an Accelera face-to-face over at Synopsys. So a lot of those people were involved in System Verilog, so they will be coming over during the lunch hour. So we're going to introduce the first speaker, and it's Daniel Armbruster. Very, very impressive bio. I'll read most of what he sent. Lots of good stuff. Let me just go through it, and I'll have Daniel come up here. So Daniel Armbruster is CEO of Silicon Catalyst. A lot of you have already heard because of their event a couple months ago at Avaya Stadium. Silicon Catalyst is the industry's first incubator for semiconductor solution startups. Okay, and Silicon Catalyst is addressing the challenges faced by early startups. I don't need to read that, right? We have an issue for startups in the silicon semiconductor industry, and Silicon Catalyst is there to help provide guidance and mentoring and facilities and so forth for this kind of a group, and I'm sure Daniel will speak a lot more about that. He is responsible for recruiting strategic partners to invest and mentor a portfolio of innovative startups and develop them for further seed investments or acquisitions. So in terms of what he's done in the past, he was most recently president and CEO of Semitech. This was from 2009, 2014, for responsibility to lead that consortium's advanced technology R&D programs. I think we all know Semitech. We know the good work they've done, so we don't need to go a lot further there. Dan Armbruster was there. He also, though, has more than 25 years before that at IBM, culminating in his tenure as vice president of 300 millimeter semiconductor operations, where he was responsible for the operations of the IBM 300 millimeter fab in East Fishkill, New York. You can see this is a person with lots of background, lots of insights I would expect for us as we begin this symposium. Mr. Armbruster earned a bachelor's degree in ceramic science and engineering from Penn State, as well as a Master of Science degree in manufacturing systems engineering from Rensselaer Polytechnic. So, as I say, a very impressive bio, and I'm looking forward to his presentation. So, Mr. Armbruster. So, this works as you would expect.
I'll try to stay behind the microphone because I know they want to record my voice, but I tend to roam, so someone put me back in the cage if I start to do that. I'll be okay. Thanks for the warm words. I don't know about all that, but you're only as good as what you do tomorrow. So let's carry on with that spirit. I guess I get to advance the slides. Just three basic topics here. I want to talk a little bit about how we got here because I think the past informs the present and the future. Talk about what Silicon Catalyst has been doing to address innovation in the industry, one of many efforts. And then why am I here? What does this have to do with standards? So I always like to start out with economics. We've had a virtuous cycle for over 50 years, driven by Moore's Law, but when thought in dollar terms, fundamentally this is an innovation industry. And the specific innovation is sweeping functionality onto silicon. And with that comes new applications and solutions which drive industry revenue. And a healthy portion of the revenue is plowed back into R&D, which further drives innovation. And this works as long as it keeps going. And what we don't want to be is around if the cycle were to be broken in any way. And so lots of what goes on in collaborative efforts and standards and the like is to find innovative ways to organize around innovation and keep this cycle going. And so all's right, all's good. We've been in a constantly improving revenue industry, maybe with a couple stalls here and there, and another record last year. And so, of course, everything must be going well. You can laugh at that point, it's okay. Well, not really. First, our growth isn't double digits like it was in the 60s, 70s, and early 80s. It's now closer to GDP. And so that has a reality to it. If you look at the profitability, underlying profitability of the industry, it turns out that the leaders do pretty well, as measured by EBITDA, and the remaining industry in aggregate is essentially not profitable. That's not very healthy. And as well known, if you're on the leading edge, it takes quite a development resource and expense to get out the door, leading to fewer chip designs, very large projects. Doesn't mean that's not a healthy piece of the business, but in terms of one's ability to innovate nimbly, less so. And so some of those trends are fairly troubling. Along with that, we've gone from an industry that was structured around systems and solutions, and those companies would tend to be vertically integrated. They viewed design, manufacturing, assembly as a means to an end, and they could invest that way because the profits were really had at the systems level. And you know, those companies look like AT&T and IBM and the like. And today, for very good reasons, for focus, for economies of scale, we've fragmented the industry and specialized it into the IDMs, fabless foundry industry that we know, separated by the supply chain in the EDA and materials and equipment companies and packaging and OSATs. And so for very good reasons, as I've said, the industry is the way it is today. And yet, if you think about interesting innovation, you now need to innovate across company boundaries and industry segment boundaries, making it a bit more difficult to actually accomplish that because the profitabilities are often at the systems level, which is one that's being enabled, and not necessarily within the supply chain. And so the motivation to invest is complicated. And we've gone from an industry born in Silicon Valley through Fairchild and to Intel, which spawned off many others, leading to the advent of venture capital, to a industry which is consolidating rapidly at all levels. And in fact, for fun, I put this slide together about a year ago, and how many of those companies are being acquired or acquiring. It turns out that this slide is rapidly becoming obsolete, and it was meant to show that the industry has consolidated. Not the case. There's some interesting news this morning in the memory business that would suggest that it continues. On the other side is the startup part of our industry, and if you measure the amount of activity as expressed in seed and series or IPO, all trends are alarming, that we've gone from just in a short decade from a relatively stable industry, that is, that the amount of creation was equal to the amount of acquisition. Today, the amount of acquisition is unabated, but the small fish in the ocean aren't being born anymore, and the medium fish are being gobbled up. And so if you're aware of that, you realize that is not a healthy situation. And in fact, for good reasons, venture capital is hard to get because the alternatives are better, and our track record hasn't been particularly good. I would argue strongly because of some of the approaches that we've taken has been rooted in our past and not in what is actually being done in other industries. And so as motivation, if we look in areas like pharma and biotech, there's quite a healthy amount of M&A and startup activity. And you can't argue that those industries are less complex. You've got 7-year approval cycles. You've got heavy capitalization on drug discovery. You've got long lead times. And yet, they've rallied around a very innovative structure. Startups focus on specific ideas. And the thought process is you'll be acquired. And you'll be acquired for good reason. Those companies, the larger ones, are very good at scaling in manufacturing, scaling in distribution, scaling in marketing. And so whether it's Johnson & Johnson or Medtronic, that is your target. And so why would that not work in the semiconductor industry? In fact, we're looking a lot like that. We're not 50 or 100 companies. In fact, we're fewer. We have the scale. The question is, can we change the early stage of the pipeline into something that will look more like what's typical in software and biotech? And so as evidence, how do you get startups out the door? The idea of an incubation, Y Combinator is probably most famous starting in the mid-90s, but there's now lots of them. In fact, one can count over 2,000 incubators in the world, and many in software, but there are hardware-based as well. But there are none, zero, in semiconductor as exclusive focus. And so what's wrong with this picture? Are we really the most innovative industry if our pipeline for innovation hasn't caught up with what's being practiced out there, and incubators exist for good reasons? So that's sort of the downtrends, but on the other side, I think everyone recognizes that we're actually in front of a new wave of innovation. Every segment of society, it's becoming quite obvious that digitalization and advanced hardware coupled with software is driving changes in every industry. And it's widely anticipated that just Internet of Things will likely be the next growth wave, and yet, when you critically examine it, you have to wonder how we're going to get there in our present state of affairs. So there's every reason to be bullish that we're actually on another inflection point, but we can't stay static and expect it to happen. We're going to have to make it happen like we've made every other change in the industry happen. And in fact, one of, I think, the more insightful individuals is Michael Malone, who's chronicled Silicon Valley's changes over the years, has written on prominent individuals and companies. Wall Street at printing and a revolution in sensors, all tied together by a cloud-like Internet of Things. We are entering the era of devices. This will be led by builders. I think that's prophetic, and it's up to us to make Michael right, not because that's our goal, but why not? Let's make him right. And so, turning the corner on how we might want to think about this, it turns out that lots of our industry is not at the leading edge, which is problematic. It is the specialty of large companies, but the majority of designs are certainly less than 45 nanometer in maturity. And as an inspiration, Adaptiva has introduced a extremely highly energy efficient multi-core processor that claims a record for gigaflops per watt. And their introduction in the market was funded by Kickstarter. They proposed a development kit and was able to raise millions of dollars in a campaign to get them started. And so, do we need to be at the leading edge for all technologies, especially for IoT? No. And will innovation occur in interesting ways as we leverage those technologies and add on to them? Absolutely. And do we need all the traditional forms of financing? The answer is there are ways to supplement what we'd be doing. So transitioning into silicon catalyst, we went out and talked to entrepreneurs, actually 70 of them over a course of a year. This is a subset of the ones that actually took a survey. And we asked them what was life as an entrepreneur when you wanted to innovate using semiconductors. And probably not surprising to this audience, they said, well, it's really hard to get money. But even if I had it, it's really expensive and hard to access leading edge capability, the best capability, be it EDA tools, shuttle runs, prototyping, and test and characterization. It came out loud and clear in the survey. And so the question is, how could we respond to that? How could we make their life easier? Because without startups, do we really have a lot of optimism about where our industry is going to head over the next quarter century? Are we going to be able to attract the talent that we need so that when some of us are just advising, there's another generation to carry the torch? And so what alternatives do startups have? Well, most start out self-financed, friends and family, through a bootstrapping of what they're doing. They may turn to angel investing. They may go to incubators, but it turns out that Y Combinator and WeWork and the like are not particularly suited to give the right and comprehensive advice that a semiconductor company might need. If one is particularly nimble, they may go after government programs. There's good ones out there, crowdfunding. But ultimately, when you really need capital, you need to go to the strategic stakeholders in the industry and venture capital. And so there's some pros and cons here of this, but navigating this thicket, if you're not extremely savvy here, is difficult. And so the play of the entrepreneur is they need to become a businessman first, and then once they get the money, then they spend it immediately, and now they finally get to innovate. And that is not going to result in lots of success, because typically the entrepreneur has got the idea and hasn't spent a career in venture capital. And so wonder if we could take the right side of the equation, which is a little bit of money that you bring along the way, and then you need to raise a lot of money, and instead replace that equation with a little money to get started and lots of in-kind services or capabilities that the industry provides, in recognition that without startups, we don't have as bright a future as we'd like to have. And so that's the idea, the core idea around Silicon Catalyst. That is, find interesting startups, seed them with a little cash so that they can put food on the table and pay benefits, provide them with lots of heavily discounted capabilities so that you can avoid the fundraise, so that you don't spend the next year not innovating, but raising money that you'll just spend immediately and diluting yourself heavily, making the risk-reward equation not work in your favor. And instead, get right into innovation, build the prototype, engage with customers, and then you've de-risked your proposal, you're much more investables, and the traditional source of capital is accessible. And so the model here is an incubator-like operation, but you add on top of it the core things that a semiconductor startup needs. So that's the model. And in return for that, it's not a charity. Silicon Catalyst would take an equity and be aligned with the success of the startup. There's no success until there's a liquidity event. So this all relies on a heavy amount of screening and filtering, because you only want to provide these capabilities to the very best. Now, along the way, a lot of these startups need help, and we intend to provide them through a network of mentors and advisors, literally an incubation function. But at the point where you need to get serious and put services and money in and accelerate the companies, we need a fairly good ability to be able to select promising startups. And so that is really the trick here. It's an elite 5 or 10%. It's not everybody. That's the beginning of the pipeline. You put them in the incubator for not 6 weeks, not a quarter, but 2 years. 2 years is much more appropriate to a semiconductor startup where getting to silicon may take you 9 to 12 months and then some. Surround the startups with actually the industry, the eventual acquirers. This is an acquisition model. If the idea is you're going to be the next Qualcomm and IPO, you're in for $100 million in 7 years, and you're going to build out every capability within that company. We argue that that's exactly the sinkhole that many famous examples have led to VCs exiting. That's not a successful model. Take your idea, drive it into completion, get it acquired, and become a serial entrepreneur. That is a realistic business model for most of the startups in our industry. So to further refine our thinking, we are not a chip incubator. We are not about large system on chips with large design teams building a chip which is sufficiently better than other chips, but one has to sell, market, and grow that business. That is a 5 to 7 year endeavor and not particularly differentiated. Instead, we're much more interested in the other parts of the barbell. Companies that are after applications and solutions that happen to need differentiated silicon to enable that functionality. Oftentimes, you can mimic that capability with an FPGA to get customer feedback. Once you've obtained that, then go to custom silicon to get the cost performance that you need. It's a much better way. Or work on the other side of the barbell, work on a specific innovation that can be adopted in existing chip families, and think of that as an IP block that's sufficiently innovative. Both of those ends of the barbells are doable in a relatively short amount of time. The large chip semiconductor play is better left to the existing incumbents, and so we don't really think that's a good place to be. And now we've come full circle. We're now talking about systems and applications and solution-driven companies. If you remember that the industry fragmented, and it's really hard now if you're an EDA company or if you're a semiconductor company to remember what it was like when you were a solutions company, which is the start of the industry. We need to return back to solutions, and that is what, in fact, every incumbent player is trying to get back to, because they realize that at the core, the chip business is a tough, commodity-driven business. It tends to commoditize quickly. You've got to be playing with a solution stack above you to be effective, and you've got to be actually engaging with the end customers, returning back to a systems heritage. So, in fact, those are the types of companies that will be the future semiconductor companies that we think of. And so, with that idea, in April of this year, Silicon Catalyst was announced with foundational partners, selecting some pipe cleaning startups, and beginning its operations with the goal to make a difference here. And so we decided to hold a small party to announce this at Avaya Stadium. We were thinking maybe 50, maybe a little bit lonely in the brand new soccer stadium, and it turned out 750 people. 750 people showed up because word was out that something was different, maybe something that hasn't been this different for quite a long time. We announced a portfolio of in-kind partners so that we could provide leading-edge capabilities to our startups. So a startup coming into the incubator has access to the Synopsys design suite, TSMC shuttle runs at all technologies, test capabilities from Advantest and Keysight, prototyping from IMEC and design solutions, the characterization capabilities of PDF, the design software from Autodesk, more recently, the design services at a startup-friendly business model from Open Silicon, and we're going to continue to announce partners as we add vital capabilities that startups actually need. It turns out that in order to have a small team do innovation, you need the capabilities that have evolved in the industry. It's just not one or two of these. They all need to align. And so what's the motivation for our partners to do this? They certainly see many startups. They certainly try to help those startups, but they're not always aligned. If one partner sees and likes one, it doesn't mean the others see and like, and so alignment is important. And also, the amount of due diligence to figure out which ones are the better, more promising ones takes a considerable amount of effort. And so helping with that as a Silicon Catalyst function allows the industry to sort through the more promising ones. And so our first incubator location is on Xander Road in North San Jose, sponsored by Adventest. We're right next to their test floor. We assembled a very, very solid team of experienced semiconductor professionals doing various full-time and part-time activities. The key here is to be able to sort through the companies, help mentor, advise, and select the best and most promising. Larry and Dinesh and Rich are in the audience. Others are helping in various capacities. And behind this is literally a group of about 50 mentors and advisors that we selectively engage in their area of specialty. And in fact, those in the audience that might be interested, please reach out to us because it can be really fun to be working and helping startups. And you can look at this as a very sophisticated executive in residence program where you're actually going to engage with some of the most interesting ones out there. Like Obama, we were given a prize before we deserved it. In his case, it was the Nobel Prize. In our case, it was EE Times Startup of the Year, which was really nice because I think it recognizes that we need to do something different. But humbly speaking, we've yet to make our mark to deserve the trophy that was given. But to show you that this is a reality, we now have over 50 applicants since April. We typically get about 1 to 2 a week. They're primarily US-based, but our goal is to balance that over time as word gets out. IoT, wearables, data center networking are the most frequent focus of those startups, using a variety of technology, but typically ASICs, and even split between leading edge, lag edge, and fully mature nodes. So really nice diversification of who's applying. Let's go back a second. So we've go through a fairly rigorous screening process, typically leading to about 4 to 6 finalists. A quarter will pick 2 or 3. And the goal is to have about 10 in the incubator. So over a 2-year period, we'd have 20 at any given point in time. And again, the objective here is to get them screened and selected with the help of the industry. So we're looking for both system companies and semiconductor companies to participate in that screening process, advising us, and ultimately, through full visibility of their progress, co-investing and eventually acquiring. So I guess this one didn't come out quite as well, but I think you can read the words. I want to make a transition in the presentation to answering the question, what does this have to do with standards? What does startups and innovation have to do with standards? So I want to first start with the vision that Silicon Catalyst has, and it's just not helping interesting startups succeed. It's actually a little bit broader than this, and I think you can understand why we need to have a broader vision. We need growth to drive this industry, to drive the R&D that I mentioned in the first slide. We need to keep revenue to drive R&D to afford the innovation that keeps us healthy. And so the last true growth wave we had was the separation of capital intensity leading to the rise of fabless companies, where we now have hundreds of companies where smaller teams can make a meaningful difference, and indeed have done so, leading the capital intensity to the foundries. And so wonder if a small team spinning out from a company or from a university could actually make a difference in our industry, a small team. Suddenly it might be cool to be in hardware again. It's not cool when you need to go raise $5 million just to get started, and eventually your dilution is so great that you ask yourself, why did I do that? It's cool when a small team can look like a software team in a garage and actually do something. That's going to attract investment. That's going to attract vitality back into the industry. And so we need to enable that. And if we don't, I think our growth is substantially different. So standards have everything to do with making a small team successful. If you need a core team of 100 engineers to get the design out the door, it doesn't work. Now, if there's a third party that can do that, and you focus in on your innovation alone, well, that works. But there's a lot of barriers for a small team to really be effective. So how can we help them? So what do standards have to do with it? Well, fundamentally, standards are codifying, building on things that actually work. There's lots of innovation in the marketplace. We say, aha, that seems to be catching on. Let's build a standard around that. And the Wi-Fi is a typical example of maybe in the early days wasn't as obvious that it would now be ubiquitous. And if you don't have Wi-Fi, lots of things don't work. Well, that had everything to do with recognizing it quickly. And it just wasn't a standard. It was an evolving series of improving capabilities that were backwardly compatible that now the IoT assumes. Similarly, standards are about fitting things together. If they can fit together in what known and predictable manner, you can focus on innovating in a part of the ecosystem and not the entire thing. And so if we can remember what standards are really about, then we can turn our attention to what this next growth wave might look like. Go back to the idea that there would be a separation between design and production, from internally based standards to externally validated standards. Well, it turned out that that didn't occur because Morris Chang had a bright idea. It occurred because lots of companies in the industry rallied around that over a decade and began to develop standards about how to do things, how things would work together in a predictable manner. And so we got things like defined process flows and PDKs. The EDA flows became standardized and compatible versus proprietary tools. The concept of shuttle runs to dramatically reduce prototyping cost. The idea at the time, it was very hard to find a standards-based set of IP blocks that actually worked together in a predictable manner and affordable, for that matter, and on and on and on. And so all those things, the standards, ultimately drove the growth wave. It wasn't just the conception that we could separate out design from manufacturing and the capitalization intensity of those two activities. And so today, what do our startups need in terms of standardization? We would argue strongly that standards influence their top four needs, which is availability of IP and platforms around specific themes like IoT, including developers' kits and reference designs. And why is that the case? Because then you can innovate on lots of other, you can build on the shoulders of the industry versus having to start from scratch. Design services that can complement the differentiated IP, and that's evolving. And the ability to make trade-offs, because ultimately these aren't simple designs at the chip level. It's chip package system, including software. Where are the trade-off tools that can actually think through that? Think of 3D integration, for example, in packaging. Are there really sufficient tools and models that one can actually think through all this and innovate? The answer is we've got a long way to go. So returning to the higher level themes, if you add those things up, what do standards mean to today's startups? If we're good at this, it's going to enable them to have a simplified software and hardware design and integration. It's going to improve their time to market, which is critical. It is going to make those innovations compatible with emerging solutions and assisting with compliance with regulations and certifications, all critical to enter the marketplace. So I'll end then with a series of challenges to the standards community that addresses the needs of our startups. The first and foremost is to quickly adopt market-based platforms and prototypes and protocols as they emerge. And what I mean by that is we look around for market-based solutions, things that are working. We ask ourselves, why are they working, and try to develop standards around them as quickly as possible, which allows the startups to build off that innovation. The second is we've done a great job in the hardware space defining standardization and flow. But if you're innovating at the systems level, very hard to pull the IP together in an effective way. And so as an example of that, this is a typical flow in an EDA company. And this is fairly well recognized. The design community will be able to recite this. They know where they fit in. They specialize in each one, and the handoffs and the protocols are pretty clear. In fact, there's not much left to chance in this model. But if you think about it at the system software level, that roadmap doesn't really exist. Every systems company is on their own in a very, very real sense. And so I think we need to move our level of abstraction up another layer for these small teams to be more successful. Next is encourage our systems companies to even be more involved in standardization. I know there's low power discussions going on today, but ultimately the systems and the solutions providers should be driving those standards and being a huge part of them. And then finally, a lot of this isn't going to work if our current security and privacy standards aren't improved, and it's clear where each party needs to play here to enable some of these new markets. We're just simply not going to adopt these things if we think that all of our personal stuff can be hacked into and stolen. So to revisit the vision, it's small teams innovating meaningful solutions, leveraging custom silicon, and it has the wow factor to it. That's, you know, you want your kids to say, yeah, I'm doing this, and it's doable, and their peers think that it's suddenly become cool again. But I think it needs to be enabled by standards, ultimately launching our next growth wave. It's not going to occur in 2015 or 16. It's not going to occur because we've come up with an incubator which will be part of the solution. It's going to occur because all of us are rallying around a new set of thinking that's going to make our industry easier to deal with and easier to innovate. And with that, I'm profoundly optimistic about that, and I certainly encourage any questions before I wrap up. So thank you.
Okay, if you have a question, I have a microphone here. This is being recorded, and if you don't use the microphone, your question won't be heard, and might not be heard anyway if you're in the back. So questions? Shishpal?
So, Shishpal Rao from Accelera. So, Dan, it's good talk. One of the things I'm interested in finding out is standards for the next level of abstraction. Can you say a little bit more about it as to what the next generation of system developers are looking for in order to actually accelerate their work? Some more insight, that'd be very useful.
Yeah, my thoughts are around the idea that primarily this is where software and hardware integrate. And It's that level, and it's the level where we choose to then send information up into the cloud. And so the interfaces between those are where I think a lot of the work needs to occur. I'd be frank, though, to say that that is not my area of expertise. But in preparing for this, we had a lot of discussions, and it was really an analogy between how well we've done in our design flows in the hardware side. And when we said, well, where is that roadmap? What does that look like? Who's responsible for that? There's just a lot of gaps. And I don't know where to begin to attack that first, and I'd encourage that might be a really good basis for setting up a workshop amongst the folks that have some strong opinions about that. But just our inability to describe that problem in particular, it might be good to get some practitioners in that area and maybe help them define what they're spending their time doing. Much like when we showed the surveys for entrepreneurs and we asked simply, why is this so hard? And I think there'll be clues that come out of that.
Okay, additional questions?
Graham Bell from Real Intent. Dan, we're seeing a huge wave of consolidation in the semiconductor industry. I guess we've had more sort of mergers and acquisitions in the last 6 months than we've had in 5 years or more. How do you see this sort of wave of consolidation affecting this drive for innovation and cool stuff?
It's a great question. In the short term, it's distracting because all the folks that are leading the companies are trying to figure out what their survival strategy in the area of cheap money and consolidation looks like. So in the short term, distracting. But ask ourselves, at this point, all things, the pendulum swings. And we're left with the surviving, well-financed, capitalized companies. They are profitable, and they're using scale to their advantage. What's clear to me is their R&D budgets aren't going up as a percentage of the revenues. In fact, it might be going down a bit. So their R&D pipelines are extremely rationalized, right? These are Wall Street driven companies. There's no question in my mind about that. So there is going to be a profound need to look around the company borders for external innovation. It really drives an acquisition model, and that can be quite healthy. I mean, Google's and Apple's and the like are doing quite well with an acquisition-based model because they recognize that innovation probably occurs more naturally outside the borders, so their function is to monitor and move quickly. And so I actually think that's an extremely healthy environment for what we're proposing to go after, which is let's have a very robust startup community. Let's have these consolidated companies be quite participatory in it, and that will be a source of lots of the innovation to come. A lot of these companies have grown up through a very acquisitive strategy, and so I think it plays in well to the idea that we're moving closer to pharma and bio in terms of structure, and those industries have transformed themselves into where the innovations come from, with one exception. If the precondition for innovation is it takes a 100-person design team, we're going to be profoundly disappointed. It goes back to the vision. A small team has to do something meaningful.
Other questions? Dennis. We're going a little bit over with this, but I think it's worthwhile to take the time to ask the questions and get the answers.
Okay, then I'll try to keep my question maybe short. Dan, you brought up the success with big pharma and the like, and I think part of that model, at least as I see it, is there is government interaction or research interaction that is done and funded at university level. And a lot of this work, or a lot of this key research and insight makes its way into projects that start with these smaller companies, and then to get the breadth of reach will eventually end up in larger companies. For electronics and silicon, does the same thing exist? or is there some, at least in the United States, some fundamental relationship between private industry and government necessary? I see as I travel around the world, there are a lot of national funds that do support these type of incubation or innovation centers, but for the United States, it's left primarily as a private activity, except I would say when you point to the success of big pharma and the like, there is fundamental research done in university settings where that intellectual property gets monetized later in the private sector, and I don't know if that exists so well for us in electronics.
For the record, that was not a short question.
For me, it was.
I'll wade into the shallow part of a very treacherous body of water. First, there are really interesting things going on at the university level. Our challenge is to pull them into something that looks like commercialization. We're seeing startups come out that are very promising, but really early stage, and they struggle to make that transition. We need to help with that. I don't necessarily think that's a government program, and there are good government programs. The SBIR programs of a number of the agencies, including NSF and DOE, are actually undersubscribed in our field. In fact, we're encouraging every one of our startups to apply because you can get over $1 million of non-dilutive funding if you do your homework. So they're out there. I'm not here to say we've got to change that piece of the equation. What we need to do is we need to help the good ideas come out of the university because they're yet not interacting with the industry in sufficient ways to understand how to apply that technology into an application that matters. That's usually the gap that's out there. There's many other topics I could get into from my years of Semitech, but I'll leave it at that relative to startups.
Sushma Prasad, IEEE. Great presentation, Dan. My question is, there's a lot of development in software because a lot of information is out there. There are millions of lines of open source code that's that's reusable for people. If I want to build a garage door opener connected through my Arduino, I can do that by just searching for it on Google. But there's not much knowledge out there when it comes to hardware. There's hardly any open source hardware. So there's additional cost on innovation because you have this additional infrastructure that you have to plan for. What role does this play in actually discouraging hardware development?
Well, I think it's a huge issue because if you've got to create the entire stack, it's no longer a small team. And so reference designs, as I mentioned, hardware platforms are essential. Even if that platform looks like a Raspberry Pi or an adaptive development kit, it gets you going on a solution, which later on then you're going to go fiddle with the silicon to make it work and integrate it and reduce the cost. So I think let's just stick with your statement, which says in other spaces you can pick up from innovations because they're widely out there, known, and you can build on them. We need to be thinking about what's our analogy while still keeping some of the IP that keeps us profitable alive. I don't have great answers there, but your observation's spot on. It's why you don't wake up one morning and say, I'm going to go do this, because the barriers to entry are very high right now.
Thanks.
Okay, so I'll ask maybe the last question. Yatin Trivedi, Synopsys. So you mentioned silicon catalyst invites applications, and we're talking about standards, and many people here are related to standards. Do your applications ask for what standards they would use as part of their work and their innovation? What standards they would build their innovation on?
I would say not specifically. We ask them a lot about what application they're pursuing, what innovation they have, why is it differentiated, why they think they can sustain a competitive advantage, how they want to engage with the industry, and what are their gaps. We should probably consider asking them along in the process in a more formal way. We do not. So I think we infer it as we go.
There is some inherent
Oh, well, Yatin. You know, you had to follow.
I was saying there is some inherent efficiency in their starting point if they are building things on standards. And knowing that level of efficiency might be very helpful in judging what the value of the potential innovation may be.
Yeah, I mean, just as example, just the existence of low-energy Bluetooth allows a company to do magical things that they could never have done. And you can go on and on. Every one of the startups is building the premise of their business plan on a standard of some type, almost invariably. Otherwise, to create the standard, it's not usually appropriate that a startup can do that. So, well, thank you, everybody. Really appreciate it.